And welcome to our bonus features segment. First thing we're looking at is the total electron content forecast, showing the most likely places on planet Earth for GPS errors. We've seen a little rise in the electron flux here. It looks like the coronal hole high-speed stream is subsiding. We should see the geomagnetic unrest and geomagnetic storm conditions subsiding along with it throughout the day today. We'll let this play through one more time to show you the most likely places on planet Earth for errors in your GPS. Everything getting back to a little more organized here with higher electron flux numbers. So what you're looking at there is the total electron content forecast. It is the free electrons in between your GPS satellite and your handset. As there's a plasma sphere here, a Van Allen belt here, and another plasma sphere here, and then the rest of the atmosphere. If your GPS must communicate through a lot of electrons, it can cause errors. We also see some surface charging here, mainly over the Central Pacific Ocean, some over Florida and the Caribbean, Central America, and Mexico. Surface charging caused by low-energy electrons gathering on the surface of satellites. Here's the one-year chart of the relativistic electrons from Solon.info. And here's the 3-day measurements from the GOES 16 and 17. They use radiography to measure the electrons at the F flare from their geosynchronous near-equatorial orbits. Let's take a look at the forecast model. Here's a forecast model. Expecting a big uptick here in the electron flux in about 2 days. I would tend to agree with that forecast from NOAA. Next, we'll look at the ionosphere. The F flare is located at about 300 kilometers of altitude. Here's the animated ionogram. We're seeing some significant anomalies here. And for you new viewers out there, we'll show you the anomaly gram as well. So here's the anomaly gram showing anomaly in megahertz from the 30-day median. And some pretty wild swings actually happening here in the past day. You can see some sudden high to low frequency shifts happening there. When you see a red to blue shift in the same geographic region, that's a huge shift. From low to high, vice versa. Blue to red, high to low. And not surprisingly, a lot of those are centered around South America. The weakest point in Earth's magnetosphere is right about here. The South Atlantic anomaly, now over the South American continent. Here's the latest image, ionogram 11:15 Universal Time. There's the anomalygram, 11:15 Universal Time. And here come additional bonus features. It's the ground-based solar observatory at Udaipur, India, rather. Udaipur, India there, showing a bunch of filaments. You can see these absorption features up here, some absorption features down here, showing up as dark areas. Those are plasma filaments suspended in the solar corona. Will they end up headed toward Earth or not? Headed toward Earth or not? Let us know in the comments what you think. Also, you can see some minor prominences around these areas. Here comes additional bonus feature. It's the latest intensity gram and the latest magnetogram. Got some anomalies showing up on the magnetogram. Let's take a look at sunspot 29, 57, and 61. Those are still beta class sunspots. 2960 is just huge and quite capable of producing large flares. 2962, I believe it's growing. See our previous videos for more details on that. Here are the magnetic fields of 2962. There's 2960. And there's 2957 and 2961. We got a great prominence showing up here on the NASA GOES 16 SUVI. This great prominence up here in the northeast. Quite a good one, and all kinds of features are telling us The sun is jumping up and down and yelling, "Hi, this isn't a grand solar minimum. It looks nothing at all like a grand solar minimum." There was a reason why I didn't have those words coming out of my mouth for the last 3 years every day repeatedly, and it's because I wasn't convinced. And now you can be assured that this is not, at least during this solar cycle, a grand solar minimum. It has none of the features to suggest that it is. We'll close out this bonus segment with 171 angstroms, the house favorite for SDO AIA ultraviolet wavelengths. Thanks for tuning in. Congratulations on realizing the channel exists. And may that solar wind be at your back.